Assalamualaikum and good day. My name is Ahmad Hanzalah bin Hani. I'm from 4 BEEA1/2. First of all, I want to thank to my panel 1 and panel 2, TS Maslan bin Zainun and TS Sulaiman bin Sabikan for giving me an opportunity to present my bachelor degree project 2. Next, I would like to thank to my supervisor, Puan Rohaina binti Jaafar, and my co-supervisor, Encik Arman Hadi bin Azhar for guiding me from Bachelor Degree 1 until Bachelor Degree 2. Next, I would like to thanks to my beloved family and also especially my beloved parent, my father Hani bin Yang Kasim and my mother Arba'iyah binti Zainal for always support me and encourage me for doing my Bachelor Degree project 2. Now we will proceed to my project. So my title project is Piezoelectric Generation at Pedestrian for Street Lamp Application. Okay, so let's see the introduction. Okay, for introduction, piezoelectric is common energy harvesting source that is process of energy extraction, conversion and storage which can be produced by heat, vibration and movement. The word piezoelectric is derived from the Greek piezein, which means to squeeze or press, and piezo. When pressure is applied, piezoelectric effect will convert mechanical energy into electrical energy. Piezoelectric generation at pedestrian for street lamp application using a piezoelectric for generate energy. So for the problem statement, increasing global consumption may contribute to a global warming. Piezoelectric is one of the renewable energy that is easy to reproduce electricity. In nowadays, there is many of renewable energy that has in this world, okay, such as solar, wind turbine, hydro, waveform, and so on. Okay, people normally do in their life is to walk. There is a dynamic compression on every step that takes. Piezoelectric can be used to generate energy and supply it to a street lamp at the pedestrian. Okay, rather than wasting, we can use it to generate energy. Okay, so the aim of this project is backup power source and to recharge a storage device, and also can minimize the chemical wastage generated by replacing a battery, and this is also can contribute to lowering the maintenance cost. Next is objective. Okay, objective for this project is to develop a project that use the function of piezoelectric to generate energy and store it into the storage circuit. To evaluate the amount of energy that can be produced through the piezoelectric sensor for the LED usage. So, this is my research methodology flowchart for my project. This flowchart will start with the LCD will turn on and show the value of the voltage, current and power. Next, human will step on the piezoelectric and generate the AC voltage. Okay, for my circuit, I'm using a direct current voltage. So, the AC voltage will transfer to the DC voltage using a rectifier bridge. I'm using a Schottky diode for this project. Okay, so the energy from the DC current from the piezoelectric, it will store into the lithium polymer battery. Okay, next, I'm using a PIR sensor. Okay, why I'm using a PIR sensor? Because it can reduce a wasted energy that are not used and save the battery lifespan. Okay, so next the detection motion will detect a motion and then the LED will on for 20 seconds, and then this process will repeat until the switch button manual will press. Okay, next is this is my project hardware. Okay, this is my result analysis for my hardware. Okay, from here we can see I have made a few experiment circuit and took it the data and present it into a graph. Okay, there is a 3 graph. Okay, the first one is about the supercapacitor. I'm using a supercapacitor. The second one is using the energy harvesting module LTC, and then the third one is using a TP4056. Okay, all this graph I'm using a circuit that connect in parallel. For the first graph, okay, as you can see here, I'm using a different number of piezoelectric. Okay, there is 4 unit, 8 unit, 12 unit and 24 unit for this experiment. Okay, for the blue line, it's representing with load and the orange line is representing for a without load. Okay, the without load voltage for 24 unit is 18.9 volt, and then without load is with load is 0.633 volt. For the second graph, I'm using 4 unit, 8 unit and 12 unit. Okay, the blue line is representing with load, the orange line is representing without load. Okay, as we can see here, without load it generate until 15.3 volt. The without load, with load, it representing 3.2 volt. Okay, we can see this, there is a big difference from with load and without load. For the third graph, I'm using TP4056 module, and I'm using a different number of piezoelectric for experiment, that is 4 unit, 8 unit, 12 unit and 24 unit. As we can see here, orange is representing for without load and blue is representing with load. Okay, the without load voltage for 24 unit is 22 volt, and the with load for 24 unit is 2.4 volt. This show a different voltage with load and without load. Okay. Next is the graph for my final result method that I'm being used for this circuit. Okay, this graph is show that the number of step vs the output voltage for charging capacitor and battery. Okay, the blue line is representing for the capacitor charging, and the orange line is representing for the battery charging. Okay, as we can see here, the 3 volt voltage will produce after, for capacitor will produce after 55 step, and for the battery it takes 148 step to reach to 3 volt. Okay, why this is different? Because of the size of the storage. Okay, the bigger the battery, the higher the step needed to charge the battery. For the conclusion, I can conclude that all the objective for this project, piezoelectric generation at pedestrian for street lamp application, has been successful achieved with generating the piezoelectric energy and charge it into the charging circuit. The development of the system can be used at the pedestrian also have been achieved with the function of the PIR sensor module. This also help to reduce the wasted energy that are not used and save the battery lifespan. Next is the reference. This is the sum of reference that I use for my literature review in chapter 2. So next I will explain my hardware and demonstrate it. Okay, right now for the hardware part, okay, I will demonstrate my project. Okay, this is the illustration for the roadside, and then this is the for pedestrian. Okay, this is my circuit board, and then this is for LED. Okay, first of all, my main component is piezoelectric. Okay, this is consist of 6 sets of piezoelectric that connect in series parallel. Okay, this piezoelectric connect to my board. That is here. Okay, will show. Okay, this is my hardware part. Okay, this is my circuit. Okay, the piezoelectric will go to the Schottky diode. There is 6 set of Schottky diode. Okay, and then go for the capacitor. From the capacitor, will go to the module sensor PIR. Okay, and then will go to battery lithium LiPo. Sorry. My rating for battery is 140 milliamp per hour, and then 3.7 volt. Okay, and then I use the INA 219 for the current and voltage multimeter, and then the system run about for the system for INA, it will run using the Arduino. Okay. So now I will demonstrate how my project works. Okay. Okay, first of all, for manual, we use the off on button. Okay, okay. So the LED will light up, and then the voltage for the battery will run. Okay, and then this OLED display will appear the voltage, the amp, and the power. Okay, as you can see, 3.0 volt something running voltage, and then the ampere is about 7 to 8 milliampere, and then the power 2.4 milliwatt. Okay, so after, okay, if there is no one, okay, there is the PIR sensor. Okay, if the sensor not detect any motion, and then it will turn off about 20 to 25 seconds. Okay, it will detect around 2 to 5 meter. Okay, so now I will demonstrate how it will charge, the piezoelectric charge. Okay, we punch this. Okay, we step, and then the voltage will increase, as you can see there. Okay, so that's all for my demonstration for my hardware part.